Ladies and gentlemen of AstriCon, please put your hands together for Danny Wyndham, CEO of Digium.
Good morning. All right, all conference party was not last night, that was weak. Good morning.
Good morning.
All right, that's better. I am Danny Wyndham, and I would like to welcome you to AstriCon 2010, where together we are changing the world of communications. The theme for this year's conference is Asterisk, the world is calling. That theme was chosen because it has a dual meaning. On one hand, people all over the world really are calling using Asterisk. On the other hand, the world is calling because so much of the world is in need. And today, humanitarian organizations are utilizing Asterisk to help make the world a better place. Over the next 2 days, you're going to hear how Asterisk is enabling both interpretations of this theme. I want to thank all of the attendees for being here. And in fact, some of you are up there on the stage, and I say you look marvelous. I understand that for getting here, some of you was no small accomplishment. We have attendees that have come from halfway around the world. And in true conference organizer nightmare fashion, the guy on the 11 o'clock news last night said, and over 500 flights were canceled today as the biggest autumn storm system of the year rolls into Washington, D.C. So whether you came halfway around the world, or whether you braved the elements, or both, thanks for being here. This is the 7th AstriCon, which in itself is hard to believe, since this is the conference and expo for all things Asterisk. We have over 700 people in attendance this year, which makes this the biggest AstriCon ever, and also makes it one of the biggest open source conferences on the planet. This conference would not be what it is were it not for our incredible sponsors. This year we have 35 sponsors from 4 continents. We have hardware vendors, we have software vendors, we have solution providers, we have carriers, and more. And they're all hanging out down in the expo in order to help you understand how their product or service can help expand the power of Asterisk for you. So I want to encourage you to go by and visit all of them. The expo is down 2 floors toward the river. I also want to thank our media sponsor, TMC, for all they have done to help promote and actually put on this conference. I want to thank our community members, the end users, the developers, systems integrators, the cheerleaders. Thanks for all of your tireless effort over the last year to help make Asterisk what it is today. Were it not for you, we'd probably all be out working for Cisco or something. No. Just kidding, not that working for Cisco would be bad or anything. Over the next 2 days, we have 45 sessions planned across 4 different tracks. Those tracks include Asterisk Essentials, which, as the name implies, would allow you to get access to the essential information you need to know about Asterisk the project. Case studies, where you have the opportunity to understand how other organizations have utilized Asterisk to help solve some pressing world problem. Third-party add-ons, which would introduce you to pretty much anything that would connect to Asterisk. And platform solutions, where you have an opportunity to see what sort of applications are being developed utilizing Asterisk as an engine. So, while you're here, please relax. Enjoy yourself. Make some new friends. Reach out to other members of the community. Maybe have your photo taken with Mark Spencer. Mark. Maybe hoist a pint with the jolly old Englishman like David Duffett. Maybe talk Allison into customizing a message for your voicemail box. Might I suggest something like, "Hello, you've reached the voicemail box for Danny Wyndham. He's at AstriCon, and he's having so much fun he's probably not going to return your call. But if you insist, please leave a message after the tone." All right, so much for a bad Allison impression. Remember, AstriCon has lots to offer, but it's up to you to take advantage of that. So please, over the next 2 days, make every effort to take advantage of everything that AstriCon has to offer. Now, I'd like to introduce our keynote speaker for the morning, Mr. Kevin Fleming. Kevin emerged as a leader in the Asterisk community before joining Digium more than 5 years ago. Today, Kevin plays the role of Director of Software Technologies within Digium, a role in which he is very influential in shaping the future of Asterisk. With the help of some long-term Asterisk community members, Kevin is going to talk about the future of open source communications and plans that are being made today to transform that vision into reality. So please give a big AstriCon welcome to Mr. Kevin Fleming.
Thank you, sir. Well, good morning, everybody. Thank you for coming. We have this room just about full, and luckily I see lots of friendly and familiar faces, so that's good. That'll probably make this go a little bit easier. So 11 years ago, Mark Spencer released this little project called Asterisk, which in that time has turned into the largest force for change in the world of telecommunications. It has provided open source tools for people to build voice-based applications to solve problems in their businesses. And it has made its way into countless applications around the world, citywide municipal deployments, even installations that will call you to tell you to water your plants when they need water. In fact, it has delivered telephony to the masses without restriction. On top of all of that, the world has moved to voice over IP, and Asterisk has been the backbone of that occurring. No other platform has as much reach or as broad a usage as Asterisk does. In fact, Asterisk will be downloaded 2 million times or more this year. And just last week, the Asterisk development team released Asterisk 1.8 with lots of new and exciting features. And they're already hard at work on Asterisk 1.10. You can actually hear more about that during a talk tomorrow afternoon by Russell Bryant and Leif Madsen, and probably some other members of the Asterisk development team. But right now, we're going to take a short look at exactly how big the Asterisk world has gotten. So this room holds about 800 people, although we don't actually have 800 of you here, but just imagine 800 people in here. In the past 7 years, there's been 9,800 people who have actively helped in the development of Asterisk. That's enough to fill this room 12 times. It's even enough to fill this massive hotel that everybody gets lost in 5 times over. Now up on the screen, you can see a picture of a city called Scranton, Pennsylvania. Those of you from the US probably are familiar with this as the home of the NBC sitcom The Office. What you're probably not aware of is that there is an online community that is actually the same size as Scranton. It's the asterisk.org community. Right now, there are 73,000 members of the asterisk.org community, same size as a small city, believe it or not. Turns out that's actually even enough people to fill Lambeau Field, home of the Green Bay Packers. Now, we're talking about big deals, so let's talk about another one. If you had 1 million servers, what could you do with that? Well, you could certainly build a Google, although we have one of those already and everybody's pretty happy with it. You could build 2 Microsofts. You could even build 10 Facebooks. But what we see is there's at least 1 million servers around the world running Asterisk right now. We can even have a map that shows you where all of these Asterisk servers are, kind of like the maps you see in cell phone carrier commercials. There are Asterisk servers that we can verify in 162 countries around the world. There's a few on that map that aren't orange, although it's kind of hard to tell on the screen. We're pretty sure that there's actually Asterisk servers in those countries too. We just can't verify that. So, if every user who has a phone attached to an Asterisk server made just 1 call every day, there would be over 3,000 calls made just in the time it took to say that sentence right there. Now, in that 11-year time, Asterisk has become something that has changed the way everyone communicates. It's used all around the world in countless ways. However, we have heard from a lot of people that there are ways that they would like Asterisk to be better. So today, we're going to have 3 of our longtime community members tell you some stories about the way they use Asterisk and their wishes for Asterisk and how it could be better. The first of those is Tim Panton from phonefromhere.com, who's going to tell you about how he helped to deploy mobile communications on a very small island in the Pacific called Niue. Tim?
So I'm Tim Panton from phonefromhere.com. Normally we bring voice to places where it isn't like websites, but in this particular case we brought voice to a small island in the form of GSM connectivity. Now, when I first started this project, I didn't know where Niue was, and I'm sure that almost none of you do either, so I will do what I did first time, which is to Google map it and see where it was. Well, it's an island, okay, that's good, but where is it? So I zoomed out a little to try and see, and that didn't tell me a great deal. And it still didn't tell me a huge amount. So I zoomed out some more, and finally I start to get a few clues, but I'm really not that good at geography, so I don't know where we are yet. And okay, well, we're in the middle of an ocean. No. Yeah, okay, now I know where we are. We're halfway between New Zealand and Hawaii. So basically a long way from anywhere, kind of like Huntsville in that respect. So getting to Niue is kind of interesting because there is one flight a week from Auckland. There's one boat a month, but that's not a ferry, that's a cargo boat. And otherwise, the only way to get there is hitch a lift on a passing yacht. So you have to plan ahead, and you have to take what you want to, what you're going to need with you. So, and the flight is just astonishing. You get on a flight at about 9 o'clock in the morning on a Saturday, the one flight a week, and you arrive at lunchtime the previous Friday. So when I first heard about this project, it was actually indirectly through the Asterisk mailing list. There was a question on the Asterisk mailing list from David here, David Burgess, about he needed some help with the OpenBTS project, and I happened to know the answer, so we emailed him, and I learned about OpenBTS. And at some point later, I got an email which said, from somebody who claimed to be responsible for the economic development of a small island, who wanted my help with a project. And it turns out it actually wasn't spam. So I Googled the guy, and he is, and so the project. And so I dug into the project, and what they were aiming to do is to bring a low-cost GSM telephony, so mobile phone coverage, to an island that had no mobile phone coverage. And so I got the T-shirt and went out there, and that's what we did, and met some interesting guys, and we put this pilot project together. So Niue is surprising in so many ways, but I don't know, maybe some of you are old enough to remember what it was like organizing a day for a distributed team when you didn't have a mobile phone. Okay, when mobile phones weren't there, what you had to do is start your business day with a meeting. There was a team meeting in which you planned how the day was going to go and who was going to go where and what they were going to do. And then through the day, the team members had to go and do those things, even if it turned out they weren't necessary, because otherwise they wouldn't be in the right place, and you wouldn't be able to find them. So that still happens in Niue, because they don't have mobile phones. So they have a kind of hack for it, though, right? And what they do is they wave a lot. So they wave. Whoop, what happened there? Right. So they wave a lot. And what this means is that you can go to somebody and say, did you see where the radio guys went? And they say, yeah, sure, they were going that way. And you drive along a bit and ask again, and you can find them. Now, this works on an island of 1,500 people, but it's kind of not really modern real-time communications. So they wanted a GSM network. And we used the OpenBTS, which is an open source product, in combination with Asterisk to provide an open source network, open source GSM network, which they could use with their existing GSM mobile phones, which they've all got because they all holiday in New Zealand or Hawaii, but typically New Zealand because that's where the flight goes. And so they all have these things, so you can just provide them with telephony that way. Now, one of the great things about using Asterisk in this context is that it's configurable. We were able to build the thing in the way that they wanted. And an example of that is provisioning. Now, provisioning on Niue consists of taking your phone and walking to the, or driving to the telecom office, taking it in, saying, I'd like this provisioned, because that's culturally the way they want it done. And with Asterisk, we can set that up. Now, the other thing about NUI is because it's so far from anywhere, they are incredibly self-reliant. And we were asked, or David, in fact, was asked in a radio interview, how this new telephony system would be different from all of the other things that have been put on the island, the proprietary systems that have been put on the island, that they can't maintain. And David's answer was a really good answer in terms of the open source philosophy, which is that you have all of the documentation, you have all of the source code, you have all of the diagrams of the hardware here, and you could build another one from that data. And we provided them with all of that information, in fact, with one exception, which was the antenna mount, because we brought the wrong one, and these guys had to build us one instead. So, and this mechanical PBX is really in the telecom office, and it's there for a very good reason. It is the absolute last resort phone system. If they have a catastrophe there, and they have them. They had a cyclone in 2004 that pretty much wiped the island out. If they have a catastrophe there, they can fall back to that. So fault tolerance is a big issue for them. And we only built a pilot network, so we had a couple of Asterisks, and they talked to each other and this kind of stuff. But that's not real. You know, if one of them went out, the system would probably not deliver. So what we would have liked and what we would want to do is to build something that was more fault tolerant than that. And so my wish for the future of Asterisk and for the future is to have something where it is easier to build a loosely coupled, fault-tolerant network of Asterisk systems.
All righty. Thank you, Tim. So unlike most of us, Tim gets to take a vacation to this tiny island out in the Pacific. Turns out they needed Asterisk too. So next, we're going to hear from Alistair Cunningham of Integrix. He's going to tell us about NSwitch and how they use Asterisk to build solutions for their customers. Alistair?
Thank you, Kevin. Good morning, everyone. I'm Alistair Cunningham, founder of Integrix. As some of you may know, we're the creators of NSwitch. In early 2005, with voice over IP rapidly gaining in popularity, we saw a market need for a scalable, affordable, carrier-grade soft switch for commercial telephony services. Other products on the market at the time were either feature-limited or priced unaffordably, so we began our NSwitch project. Immediately, we were faced with the question of which platform to use for telephony. Well, as luck would have it, we were aware of a small open-source project called Asterisk. Fortunately, over time, that project has become rather successful and a large open source project, which is why we're all here. NSwitch was originally planned for hosted PBX services, but we quickly expanded to include residential services, SIP trunking, number translation, and similar services. We decided to include billing and invoicing and resellers from day one, and today, with a lot of effort, we've built the best solution on the market. We chose Asterisk because it's an excellent platform for building high-level telephony services. It provides abstraction for a number of protocols, such as SIP and IAX. It supports a wide array of hardware. It provides real-time database-driven configuration. And most importantly, from our point of view, it provides the fast AGI and manager interfaces, which we use to connect to a full routing and billing engine. With NSwitch, customers can build very large, very scalable systems with hundreds of thousands of users and many thousands of concurrent calls. Since one Asterisk machine can't handle, for example, 200,000 users or 50,000 concurrent calls, we use multiple Asterisk machines in parallel to achieve scalability. This, however, raises a few challenges. Firstly, at the time we created NSwitch, Asterisk didn't know about state on other machines. It didn't know what calls were active elsewhere in the cluster, and it didn't know which handsets were registered to which machine. This meant that features like busy lamps, queue status, conferencing, we're limited to a single Asterisk machine. To overcome this, we implemented an external SIP proxy and registrar and added lots of our own code to distribute state information throughout the cluster. A second challenge is when deploying machines, we needed to know which machines were up and capable of processing calls, and which machines were down, perhaps because of maintenance or perhaps because of a fault. To do this, we added a service to the SIP proxy machine to send regular SIP pings to each of the Asterisk machines in the cluster. Any machine which was down was removed from the cluster, and machines could remove themselves if, for example, their PSTN connectivity was down. Overall, Asterisk has proven itself as an excellent platform for building telephony services, and in NSwitch we've created a very scalable and very feature-rich solution that works brilliantly for our customers. But if I had one wish, I'd wish for an easier way to integrate Asterisk across multiple machines for the purposes of building carrier-grade solutions.
Thank you, sir.
Thank you.
So, Asterisk being used by carriers to support hundreds of thousands of users. Probably not something anyone could have envisioned 11 years ago. So along that line, now we're going to hear from Ole Johansson, who's going to tell us about his efforts to use Asterisk in non-telephony applications. Ole?
Thank you. Good. Kevin, Danny, I mean, I'm from Sweden. You saw the flag? Lutefisk, Norway, Volvo, IKEA, ABBA, Sweden. Oh, well. Hello, AstriCon. Cool. Thanks, Danny, for warming them up. It's great to be here. And it's amazing. 700 people. I don't know what we started, Steve. 700 people over here. But you guys, do you really know where it all started? Some of you were with us. The first AstriCon was a dinner in California in the spring of 2004. Steve and I visited the VON conference, the greatest conference on earth about voice over IP. And we invited people to a dinner. And why we didn't call it AsteriskCon or AstriCon, I don't know. Steve came up with AstriCon and it worked. But this was the first AstriCon. Great. We had great food in California, and in the conference, I still remember Jeff Pulver and Carl Ford pointing to me and Steve saying, watch out for these guys. They're the gorilla. They're going to turn your world upside down. Yeah, we're the gorilla. That was when Steve and I decided to create a much better conference than Jeff Pulver did. And our conference is still alive, right? So, many years of guerrilla work, turning the telco world upside down. And back then, telephony was cool. Moving telephony over IP. Yeah! Right. Gonna make a revolution. Gonna be the next Vonage. I don't know how many offers for stock options Steve and I got, but, well, there were plenty. But telephony was cool. Where are we today, many years later? Well, when I build new applications, when I create solutions for my customer, the scope is much wider. Back in Edvina, our mission is to build open, unified communication platforms. Open, unified communication. Ah, that's buzzword bingo. But it means a lot for me, right? Open. Open standards, open source. Unified communication, not really telephony. Because you want to do much more. You want to chat. You want presence. Now, in the world of green pressure, we want teleconferences. We want video sessions. We want much more than telephony. So, we got a changed perspective here. Open unified communication means multiple applications in one platform, right? Multiple applications where telephony is only one of the applications you want to run. So, let's go back and look at Asterisk. Asterisk is the best multi-protocol, modular, open source PBX there is, right? Yay. But it's only telephony. So, I started going from this, seeing, can I change this? It's such a cool platform with all the modules and all the stuff that Mark built and the rest of us appended to. So I went ahead and looked at one application. Let's say we start with chat. I started looking at it, and Josh Kolb moved in, added some code, and we really tried hard, but the architecture was built upon a call, a phone call. A single chat message across the PBX just didn't work. We couldn't do that without changing the whole infrastructure in the PBX. Okay, next. Looking at video. We want video. And I worked with great Tandberg screens, you know, HD, cool stuff. Hooking up to Asterisk, getting a video call, yeah! Stamp size in the middle of the screen. So I started working with video. We started Asterisk video mailing list, and we got a lot of code from contributors. I started managing that, and we got full screen. But the way we had to change Asterisk, not doable. But we realized we really had a problem with the way we set up calls. So another roadblock, hitting the wall again. Then, I mean, everyone here is using MSN, Jabber, right? Why can't we have that inside of Asterisk? Can't Asterisk be multi-protocol presence? Not just phone call, blinking lamps, boring stuff, but presence. Managing that across all the protocols, like we manage all the voice protocols and stuff, and integrating that with PBX is a cool thing, right? Guess what? No. Didn't work. So I hit another roadblock. I felt alone. Poor me, sitting up there in Sweden, roadblock after roadblock after roadblock. I mean, come on. You end up sitting on the beach, thinking the big thoughts about life, the universe, IPv6. And, well, at meetings with other developers and Asterisk users, conferences, training stuff, I realized that, hey, I'm not alone. There are other guys that want to change stuff. And they came to me and started asking about how to interface Asterisk with their applications. And going into trainer mode, I said, well, you know, we have the manager API, AMI, and we have fast AGI, and we have this and this and this. And they said, no. And they started discussions and talked about trains and jewelry and stuff I didn't understand. We were on different planets. So I restarted and said, well, you know, we have all these APIs. And I said, no, 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 we want to do this and this and this. And I realized they don't even want a PBX. They don't want interfaces to the PBX. Like me, they want to rip Asterisk apart, turn it inside out, and get in there and change the structure. Add new applications to our infrastructure. I wasn't alone, but I was clueless. I had no idea on how to make this happen in the current code base. We still haven't fixed that. So my wish, and please help me here, my wish is to add extensibility. I want to add all these applications to my Asterisk because we need an open, unified communication platform with Asterisk. Thank you.
Thank you, sir.
Thank you.
So before you change the next slide, just be thankful that Ole did not show you his slideshows of Swedish winter, because that's it. So We've heard about Asterisk being used to provide communications for an entire nation of people, a small one, still an entire nation. Asterisk being used by carriers as a carrier-grade soft switch for hundreds of thousands of users. And we've also heard about how the world has changed in ways that move beyond what Asterisk was designed to be able to do. So today, we're going to talk to you about how we intend to grant those wishes. It's been 11 years. During many of the last years, especially at events like this one, lots of Asterisk users like you have asked for things to be able to make Asterisk do stuff it doesn't do right now. You want to be able to scale it easily, transparently, in large quantities. You want to be able to have fault tolerance, calls that don't fail, even if a server goes offline. They want to be able to make new applications, like Oli was talking about, using APIs that are designed for application developers, not necessarily APIs for controlling a PBX. So in late 2009, a bunch of us at Digium sat down and said, what can we do to try to address these concerns? We hear this constantly. Something needs to be done about this. We spent a lot of time, did a lot of research, a lot of discussion, and the result was, unlike what Oli said, we're not going to rip Asterisk apart. Ripping Asterisk apart would be incredibly disruptive to all of you, the Asterisk development team, everybody who's built applications on top of Asterisk. So we decided the best way to address these concerns was actually to create a new open source project, a companion project that would be used alongside Asterisk to address these concerns. Doing that, instead of retrofitting Asterisk, would mean we got to start over. We could go look at what are the best tools that exist now. What languages could we use? What architecture could we build this on? What platforms could it run on? Lots of things that we can't really do with an existing code base. So that, of course, resulted in months of research. And then, in March of this year, we had a mini summit in Huntsville. We brought in a bunch of Asterisk community members from all around the world, even as far away as New Zealand, which is pretty far from Huntsville. People that names you'd recognize from our mailing lists and from development, and people who we were pretty sure would represent your interests when we proposed things to them. So, of course, we then proposed this idea to them. And most of them, when they came, didn't actually have any idea what they were coming for. They literally just knew they were coming to Digium to talk about these concerns and how we were going to go about addressing them. So we proposed this new project, what its architecture would look like, what our vision for it would be, and what it would be able to do in the future. As you can imagine, people have been using Asterisk for a long time and have built solutions around it, thought about this and went, wait a minute. Lots of intense discussion. We could even call it arguments to some extent. But after a couple of days, the group realized, yeah, this is the right thing to do. So then, a few of us at Digium moved off to try to design what we would build. How would we do this? What architectures would we use? All of that sort of thing. So we at Digium, starting with Mark, of course, and all of you, have been changing communications for 11 years. Today, we're actually going to disrupt the communications world all over again. We're going to talk about the next chapter in the open source communications revolution, because today we are introducing a new open source project, the Asterisk Scalable Communications Framework. Yay, people are happy. Woo. So, the project really has 4 goals. They are the performance, scalability, extensibility, and fault tolerance. Well, actually, I got those out of order, but we're going to talk about those in a few minutes anyway. First, I'm going to describe to you how Asterisk SCF is different from Asterisk, which you're all familiar with, using an analogy that hopefully everybody will understand. Asterisk is actually a lot like a kit car. It comes with a lot of parts. You can use them to make a car. You can use them to make lots of different kinds of cars. And really, if you worked really hard, you could make a bus out of it. But that's about as far as you could go. Asterisk SCF is actually more like a collection of parts, parts that you could use to make all kinds of different transportation. The parts that come with Asterisk SCF all do a single thing. They can actually even operate independently of each other. And that leads to lots of benefits, which you're going to see in a few minutes. The first way that that's different, we can describe by talking about Asterisk the way it is right now. With Asterisk, all the parts of what Asterisk does are combined into a single process. They aren't separable components. So that's sort of like the way a car is built, or in this case, a van is built. It would be really hard to take that van and turn it into that recreational vehicle. And I'm not even sure you'd really want to, but let's just say you did want to, while it was moving down the highway. Obviously, you'd have to cut it in half. You'd have to add more seats. You'd have to put in a waterbed. You'd have to put in a hot tub. All these things you don't want to do while you're driving your van. But with Asterisk SCF, if you built a vehicle or a communications application, it would actually be a lot more like a train than it would be like a car. It's a bunch of linked components, which means you can modify and add components while the train is moving. You can add more capacity while the system is operating. When you deploy additional components, the rest of the system just sees them and the capacity appears. Now, of course, this is all made possible by something. It's not just magic. And that's because the architecture that we chose is called a distributed application. A distributed application is components that all perform single functions that communicate with each other over some kind of messaging system. In this case, they use a very high performance and multi-platform messaging system, which also happens to be open source. And that allows those components to be located wherever you need to locate them. One computer, multiple computers on a network, computers spread all around the world, virtual computers in the cloud, whatever you need, or some mixture of all of them. It also means that the number of components you deploy is dictated just by your requirements. So if your requirements are you need to handle a great deal of voicemail, well, you'll have more voicemail components than another system might have. And as your needs change, you're only going to have to deploy the components that you need to address those specific areas of functionality. When you deploy those additional components, the system sees the increased capacity appear. Now, we're going to talk a little bit about how that architecture addresses those goals that I talked about. You don't have to understand what's on that slide right now. We're going to break it down in little pieces here in just a second. Next. There we go. All right. So the first goal that I mentioned was performance. Single computer communications applications can actually do quite a lot. People have actually run an incredibly large number of calls through single systems in the last year or two. But they're still limited by the fact that they run on one computer. And that makes them hard to scale. It makes them hard to achieve very, very large call volumes. It also means that you can't easily take advantage of cloud computing, scalable computing, whatever term you want to use for how that is done. Well, with the Asterisk SCF architecture, every component can run on a different CPU, different computer, whatever you want, but they all appear to be a cohesive system. That, of course, leads to scalability. How am I going to grow my system? Well, with traditional applications, this can be done. It's clearly not easy. Frequently requires additional applications and coordination amongst all of them to make sure all the features you want work. The architecture that we've decided on for Asterisk SCF allows for capacity to be added to an operating system. So you can see on the screen there, we've just added more capacity, and yet the system still works as a cohesive unit. This is done by following 4 design patterns, as they're called in software development. Discovery, meaning the components don't have to be configured to know where the other components are. They can locate each other on the network when it's required. Managed deployment, allowing you to just put the components you need where you need them. Distributed processing, of course, if you've put those components on multiple machines, you're going to gain the benefit of utilizing those multiple machines. And finally, breaking the application into single function components means if you put a function on a machine, you're not going to waste any resources doing functions that machine doesn't need to do. Now, of course, we had another goal, fault tolerance, which we heard about from Tim. And again, that can be very hard to achieve with traditional communications applications. They're not designed to be able to provide what we want for availability. If something goes wrong in that application, it will usually crash, and then you lose all the calls that were in process at that time. Well, the architecture of Asterisk SCF, again, with every component doing a single task, means it's possible to build replication between individual components, as you can see on the slide there. That means that all the information that one component is managing about a call can be replicated to another copy of that component on a different machine, so that if a failure was to occur, failover can happen with no disruption of service at all. And of course, we had a fourth goal, which was extensibility, which Willie talked about. It's really impossible, and no surprise at all, that when Mark released the first versions of Asterisk, he could not have envisioned what people would be doing with it today. It's impossible for any software developer to do that. So the best we can do is we can build the system so that when you come up with some creative application in the future, the system will be able to accommodate your needs. So with Asterisk SCF, much like with scalability, we have 4 areas that we're focusing on to provide you what you need there. The first are the system's APIs are all well-defined, documented, and they'll be version managed so that if you build an application on top of Asterisk SCF and a new version comes along, things will continue to work the way you expected them to work. And we have a brand new concept called extension points. These are methods that a developer can use to modify the behavior of an Asterisk SCF component without actually having to modify the component at all. Ways to change its behavior at runtime without modifying it. And then finally, based on requests from users, we're going to have broad operating system support. Linux, Microsoft Windows, Solaris, Mac OS X, I'm sure many others. And even more importantly than that, all of these things we're talking about for extensibility are available in a wide variety of programming languages. That's including C++, C#, Java, Python, and a lot of other languages, including languages on mobile platforms. So, those are our goals. We've talked about how Asterisk SCF is different from Asterisk, like comparing a train to a kit car, collection of parts to a kit car, I guess. We've also talked about what our goals are and how we achieved them with the architecture. So our next task here is to teach you about the architecture of Asterisk SCF. So this is what it looks like. For the next hour and a half, we're going to go through each one of these little blocks up there. And you guys are going to understand how Asterisk SCF works. So this afternoon, you can go start writing code and help us out. So first of all, if you brought your graphing calculator or your slide rule, you're going to need to get it out. If you don't have a PhD in theoretical physics, this might be time for you to leave the room. Bazinga. We're not actually going to do that. We're actually going to do something fun, and we'll have that discussion later this afternoon for those of you who are interested. So I mentioned that back in March, we started design and development of this, and of course we have something we want to show you now, otherwise we wouldn't be doing this keynote. We're actually going to be doing a demonstration which involves both Asterisk SCF and Asterisk 1.8. And we're going to demonstrate live call failover between 2 data centers running Asterisk SCF. One of them is going to be in Scranton, which you saw a picture of before. And of course, the other one will be in Huntsville because that's where our office is. We're going to need some helpers for this, though. So any of you who have brought mobile phones with you, and I'm sure that's not very many, who are willing to make a call for about 10 minutes to a US phone number, raise your hand. Stay in your seat and just raise your hand. Wow, almost nobody has mobile phones. What's up with that? David Duffett's going to come around, and he's going to randomly select 10 of you to participate in this demonstration.
These guys are going to need films.
That's right. If you want to get his attention, you probably, get his attention. Do something creative. Sing, dance, whatever you need. So for any of you that he gives a card to, there's going to be a phone number on it. We need you to call into that phone number. You're going to be dumped into an Asterisk Meet Me conference bridge, which you're all familiar with. You're going to be the only people in there for right now, so just hang out. We'll need you in a few minutes. In addition to those volunteers, Danny Wyndham and Mark Spencer are going to help us with this demo as well. So guys, come up here. And they're going to... Uh-oh, they took the lights away. What are you going to do now? So, all right, we all set? Great. Everybody who got those cards, go ahead and call in. So you can see now up on the stage, we have 3 data centers. These data centers are all participating in an Asterisk SCF cluster. Since those components we were talking about don't care where they live, it means you can put them on any computer in any place that you need. So let's go to the next one. So this is the rack that represents the Washington, D.C. data center. Amazingly, we're right here in, well, actually, we're not in Washington, D.C., we're pretty close. In this rack, we've really got 2 servers of importance. The first is the one that's running most of our Asterisk SCF cluster. It has a lot of components on it. But the really important one is, of course, the state replication service, the one that's going to allow us to do live call failover. Now, of course, since Asterisk SCF is really new, it doesn't have conferencing or lots of other things yet. So we also have an Asterisk 1.8 server in here. It's connected to the soundboard in the room, it's connected to the telephone network, and it's connected to the conference bridge that you all just called into. So if you're in that conference bridge, just say hello now so we know you're there.
Hello.
Is it coming out?
Hello. Yeah, hello.
Okay, it's going to be kind of quiet because otherwise we get feedback on cell phones.
Hey, you're breaking up.
All right. So, next slide, please. All right. So now we have this data center right here. This one's a lot more simple. This one's located in Huntsville, has our wonderful CEO standing next to it. It has 2 servers in it. One of them is, each of them actually, are running the Asterisk SCF SIP session manager. One of them services Danny's phone right there on that table. And the other one is the backup for the one over there, which we're going to talk about right now. This is the Scranton data center. It's just like the one in Huntsville, except it has our CTO standing next to it instead of our CEO standing next to it. 2 servers, one of them running a SIP session manager for Mark's phone, the other one running a SIP session manager as a backup for Danny's phone. Now, they're going to call into the same conference bridge that you guys are in, and they'll be in there in a second. Go ahead.
Hello, Mark. Hey, and I'd like to welcome everybody to AstriCon and thank everybody that's calling in for the first public phone call on Asterisk SCF.
Hey! All right. So now, some of you who've been around data centers may have seen things like this before. Okay, clearly you have. This is a big power switch. So you can probably guess what we're about to do. One of these data centers is going to lose power pretty soon. But we don't know which one. You guys are going to decide for us. So in Huntsville, as it turns out, in spite of the tornadoes they were having yesterday, there is a fleet of backhoes running around the cotton fields. And unfortunately, they're being driven by a union of disgruntled IT workers. Beep, beep, yeah, there you go, right? So it's possible we're going to lose power here. Now, we've also heard that for some reason, there's a school of saltwater sharks in the river outside of Scranton. And of course, the power cables run through the river, so you know how sharks are. So, anyone who thinks that it's going to be the backhoes that are going to cut power to Danny's data center, you should probably applaud now. Whoa! Whoa! Well, you might be safe, Mark. Anybody who thinks it's going to be the sharks that are going to cut power to Mark's data center. Oh! Wow, we're so surprised. We didn't expect that at all. All right, here we go. All right, so this data center just lost power completely.
You good?
They're still on the call. No disruption at all. People on the mobile phones, are you still there? Yay, all right, everybody's still there. So that was obviously a fairly catastrophic server failure. We were thinking about doing worse, but that's good enough. Now that's a fairly decent demo, but now we're really going to show you something incredible. Because the server that was servicing Mark's call, all that state was transferred over here, that means Mark can still control that call. So now he's going to transfer it to me on this phone up here on the stage. Go for it.
All right.
Are we there?
Hello, Kevin.
Look at that.
Woo.
We're there. We transferred the call. All right, so all of you that are burning cell phone minutes can hang up now because the demo's done. So the whole call was still intact. We were able to transfer it after the server that was servicing that call died, gone. Now, some of you are probably pretty adventurous and wondering, hey, can I do this? Sure, you can do this. Of course, since this is an open source project, this is all going to be made available very soon, although we're running a little behind. We'll have a developer release of Asterisk SCF available, hopefully later today. It's really basic. Its functionality right now is basically what you saw here. It can do SIP calls. It can do live call failover. Obviously, we're going to want it to do a lot more than that, but we have a lot of work left to do. Actually, that's where you guys come in. We haven't even finished designing all of what Asterisk SCF needs to do yet. This is an entirely new platform, and we're not trying to build what Asterisk is. We're trying to build something that's targeted at a different set of applications. So we're going to want you to get involved, and of course, you're going to want to be able to experiment with it. The simplest way for that, of course, is to connect it to an Asterisk server, since you're familiar with that, just like we did here on the stage, so you can hook up PSTN calls and whatever else you need. And our goal, of course, is to make Asterisk SCF be the platform that you want to use to build really powerful and scalable communications applications 3 or 5 or even 10 years from now, just like Asterisk did when it started 11 years ago. Of course, since this is a keynote, we've only scratched the surface of what Asterisk SCF is, and more importantly, what it's going to be in the future. So you're going to want to get more information. Well, the first place that you're going to be able to do that is we've set up a new wiki site. It's not live at the moment. Don't try to go there with your cell phones. It hopefully will be later today. On this wiki, we're going to have all the architecture details of Asterisk SCF, the documentation of the design discussions. We even have voice recordings of calls we've been having regularly with Asterisk community members who've been acting as a steering committee to help us figure out what Asterisk SCF should be. In addition, we've taken all the documentation that we have for Asterisk itself and put it on the same wiki, so all of you and all Asterisk users will have one place they can go to get all their questions answered about Asterisk and Asterisk SCF both. Now, some of you may be developers who have built applications on Asterisk in the past. If that's true, you might be interested in a session that's on the schedule today at 3:30, which you wouldn't have known why it was on the schedule before, about another open source project called ICE, the Internet Communications Engine. Asterisk SCF makes extensive use in ICE. In fact, it wouldn't exist without ICE, really. And all of its APIs are defined using ICE. So those of you who are application developers, that session will be a brief introduction to how ICE works and how you utilize things from an application. And equally as importantly, for those of you who aren't developers, you've probably got questions too. So we're going to have another session in this room at 4 o'clock today, which you saw on the boards as a special Q&A session, where we're going to do another presentation about more details about what Asterisk SCF is, and we'll have a couple of hours to just do questions and answers and talk about what we've built and where this is going. We hope to see some or all of you at both of these sessions, because we're really at the beginning of something amazing again, and it's time to get to work, so thank you.